proceed to our next lesson, let's have a short review or recall in our previous lesson, which is the momentum and impulse. So this activity is what we call brain drain or brain gain. So direction, you're going to read the question and choose the best answer. So if you want or if you know the answer, just raise your hand and wait for your chances. Okay? Do not answer in chorus. Is that clear, class?
Yes.
Okay. So number 1, an object's momentum can be calculated by multiplying the velocity of the object by its. Okay, what do you think is the answer? Rate. Okay, let's see if that's correct. Okay, very good. So the answer is letter B, mass. Number 2, the momentum of an object depends upon the object's blank and blank. Yes, Cindy. Okay, let us see if your answer is correct. Okay, very good. So letter C, mass and velocity. Number 3, lump is a change in momentum. Yes, Rosal. What is your answer? Letter A, impulse. Okay, let us see if that's correct. Okay, very good. So the answer is letter A, impulse. Number 4, the equation to calculate the momentum is, yes? Okay, let us see if that's correct. Okay, very good. The answer is A. This equals to mv. And last one, a car and a truck are moving with the same speed, which has greater momentum. Yes, Carly? Okay, letter B, truck. Okay, let us see if that's correct. Okay, very good. So the answer is truck. It seems to be that you really understood our previous lesson. So I think you are all ready now for our next lesson. Okay. So our next lesson is about conservation of momentum, elastic and inelastic conditions. And here's our objectives for today. Okay, can you please read? So these are objectives that we need to accomplish in our today's lesson. Okay, of course, we will encounter some unfamiliar words. That is why let us adapt some of difficulty terms by doing this what we call SciVocab or Science Vocabulary. Okay, Group 1, can you please read the word deformation? Okay, again, 1, 2, 3, go.
The action or process of changing in shape or distorting, especially through the application of pressure.
Okay. Group number 2, what about conservation?
In physics, the term conservation refers to something which doesn't change. This means that the variable in an equation which represents a conserved quantity is constant over time. It has the same value both before and after an event.
Okay. Group 3, interaction.
Refers to a process by which two or more objects influence each other's properties or behavior. This can occur through force, energy, transfer, or other means.
Okay, and last group, isolated system.
A system that does not allow the exchange of energy or other physics.
Okay, so those are the words that we will encounter throughout our lesson for today. Okay, now, so collision class. I have here some examples or some pictures that shows collision. Okay, so based on the following pictures, we can formulate the definition of collision. So now class, anyone can explain or can give the definition or meaning of collision? Or what is collision? Based on the following pictures, what do you think is the meaning of collision? Anyone? Yes, Ray.
Both of the cars go to same direction.
Okay, if both two cars are going to same direction. Okay, so is that what you observe in the picture? Okay, very good. What else? What comes into your mind when you hear the word collision?
The truck is heavier as more momentum. Thus,
Again,
the truck has more momentum than the car. Thus,
the car, in the picture, the car has more momentum. Are you sure? This is the truck and the car. Okay, the truck has more momentum than the car. But based on these pictures, how do we define the word collision? Yes, Eric.
Two objects crashing into each other.
Okay, two objects that crash to each other. Okay, very good answers, class. So when we say collision, class, it is the interaction of two objects. It is the bumping or crashing of two or more objects to each other. And of course, with that scenario, both objects can transfer their energy from one thing to another thing. So energy from one object can be transferred to the other object, and this allows a change in the object's motion. And did you know, class, that there are two types of collision? Okay, so we are going to determine or identify the two types of collision by doing this activity. So this activity is what we call DARTs, or directed activities related to text. So what you are going to do in this activity, number one, I'm going to give a reading material about the differences of elastic and inelastic collision. Then, number two, the members of each group will read the materials and discuss what they understand. Number three, after short discussion, each group will complete the table about the difference of elastic and inelastic. And number four, each correct answer is equivalent to 2 points. The overall points for this activity is 20 points. So these are the rubrics that we're going to use for our scoring in your activity. If you got 20 points, you are considered as outstanding. If you got 16 to 18 points, you are proficient. If you got 10 to 14 points, you are apprentice. And if you got 0 to 8, you are novice or inexperienced. So if you got that score, it means you need to improve more further about your skills and understanding. Is that clear, class?
Yes.
I'm going to give the material for each group. Okay. Okay. Right. post your outputs here. Okay? So I have here my scotch tape. So you can use this to post your answers or post your outputs. Okay, 3 minutes left. Last 3 minutes left. Do not need to write the whole sentence. Okay? Just pick a word that can depict your answer. Once you're done, you can post it here. But don't forget to write your group number. Okay? Okay, last 2 minutes last. 2 minutes left. For the groups that are already done, you can paste it now your outputs. Okay, 2 minutes left. Okay, then. Can you write down your group number? Are you done? You can place it here. Okay. What about the other groups? 1 minute left. After 1 minute, finish your nap. We are going to check your activity. Okay. Group 3, are you done? Almost, sir. Last 20 seconds. Finish. 10, 9, 8, 7, 6, 5, 4, 3. Okay, you can help me to fix your output here. So here's the possible answers in your activity. If you really understand the reading material, I think you will get the perfect score. So let us check. So in terms of deformation in elastic collision, so the answer is do not deform or change shape. So for group 4, that's correct. Okay. For elastic, change in shape, that's considered correct. Okay. For group 2, do not deform. Considered check. And for group 1, do not deform. So all the group got the correct answer in the first item. In inelastic collision, it easily deforms. Okay. Group 4, check. Okay. Group 3, check. Group 2, check. And group 1, check. Okay. Now let's proceed to the introduction. Inelastic, in the term of elastic collision, the answer is no heat is produced. Sorry. Okay. So without heat, correct. Generation of heat, correct. What? Okay. Generation of heat, that's wrong. Okay, that's wrong. Sorry. Okay. So without heat, correct. And for group 1, without heat, correct. And what about inelastic? Okay, heat can be produced. So with heat, check. Heat. Okay, with heat. Okay. Now, in terms of states of materials, okay, things do not stick together after collision. Okay, correct. Okay, correct. And correct. And for inelastic, things stick together. Okay, correct. Another correct. And correct. Okay. Now, for momentum, I think some of your answers are confusing. So let us check. In the form or in the word elastic collision, okay, the momentum is conserved. Okay, conserved, check. Okay, wrong. Okay. Conserved. Correct. What about in inelastic collision? Of course, in inelastic collision, momentum is also conserved. Okay, so wrong answer. Okay, wrong answer. Okay, wrong answer. So later on, we will justify why inelastic collision perform conservation of momentum. So later I will explain about that. Okay. And for the equation of elastic, M1 VI1 plus M2 VI2 is equals to M1 VF1 plus M2 VF2. Okay, correct? And correct. And for the last one, for inelastic equation, M1 VI1 plus M2 VI2 is equals to open parentheses M1 plus M2 V. Okay, that's correct. So now let us count your scores. So for group number 4, 2, 4, 6, 8, 10, 12, 14, 16, 18 points. Okay, 18 points. For group 3, okay, 2, 4, 6, 8, 10, 12 points. Okay, 12 points. For group 2, 2, 4, 6, 8, 10. Okay, only 1. 18 points also. And for group 1, only 1 mistake. So 18. Okay. So again, if you got the scores 18, 16 to 18, you are proficient. And for group 3, who got 12 points, so it ranged from 10 to 14, so you are apprentice. Okay, so you can improve that in our next lesson, of course. Okay, now let's proceed. Based on your outputs class. Okay, so what are the difference that you notice about the elastic of materials. In elastic collision, after they bump to each other, they stick or they separate. Okay. Do not answer in chorus. Just raise your hand. Yes. Okay, they separate to each other. But in elastic collision, once they bump, okay. Uniset. They move or they stick together. They move as one. Okay. So in an elastic collision, ideally, the colliding objects rebound without deformation or change in shape or the generation of heat. The total momentum and the kinetic energy are the same before and after. Okay. After collision. Formula to compute elastic collision. Okay. M1 VI1 plus M2 VI2 is equals to M1 VF1 plus M2 VF2. Please open your lab. So, as you can see, elastic collision or the total momentum and the kinetic energy are the same before and after collision. Meaning, elastic collision can conserve momentum. In inelastic, there is a great chance that heat and deformation will occur in the collision. This allows the objects to stick together and move with the same speed. Okay. So after they bump to each other, they move as one. Unlike in elastic collision, after they bump to each other, they separate ways. So the total momentum remains the same. Means the momentum is conserved, but the kinetic changes or kinetic energy changes before and after collision. So the transportation of kinetic energy is observed with the release of heat and deformation of the object. Okay, now, even though it is elastic or inelastic collision, momentum is conserved. Okay? So how? So take a look in this another TV monitor. So I'm going to show you the conservation of momentum. Okay. We have here the simulator or collision simulation. So as you can see, there's a red card and the blue card. So what is the initial velocity of red card? What? 5 meters per second. And what is the mass of red card? 1 kilogram. Okay. Now, what is the initial velocity of blue cards? Okay, negative 5 meters per second. Okay. Now, what is the mass of blue card? Okay, 1 kilogram. Okay, so in order to get the momentum, what we are going to do, P is equals to mv. So mass times velocity. So let us compute 5 meters per second multiplied to 1 kilogram. What's the answer? So we had 5 kg meter per second. And also negative 1 times 1 is equivalent to 8. Let us observe, 8. Okay. Sorry. Okay, so negative 5 meter per second multiplied to 1. What's the answer? So you can use your calculator or cell phone for calculation purposes. Okay, let's see. Negative 5 times 1 is equals to negative 5 kilogram meter per second. Now what we are going to do, we're going to add 5. Okay, 5 plus negative 5. So the answer is 0. Okay, so the answer is 0 kilogram meter per second. It is the momentum before. Okay, and let's see what will happen if we start the collision. Okay. So now class, the final velocity, positive meter per seconds. And what is its mass? 1 kilogram. If we compute the momentum of the red cards, so negative 5 times 1 is still negative 5 kilogram meter per seconds. And 5 times 1 is positive 5 kilogram meter per seconds. Now, if we add negative 5 plus 5, what's the answer? 0. 0 kilogram meter per second. So this is the total momentum before and this is the total momentum after. What have you observed, class? They change, as you can see, before and after, they are the same. So in elastic collision, the momentum is conserved or not? Okay, it is conserved. What about in inelastic collision? Okay, so let us set the simulation in inelastic collision. Okay, so I'm going to erase this. Okay, so same given data, but now we are setting the simulation in inelastic collision. Okay. So, same data, so the answer is 5 kilogram meter per seconds and negative 5 meter per seconds. So the answer is 0. Now, let us see. After the collision, okay, so as you observe, what is the final velocity of red car?
0.
Okay, that is 0 meter per seconds. What about in the blue cars? What is the final velocity? 0 meter per second. So 0 times 1 is 0. And of course, 0 times 1 is 0. So what will be our final, or what will be the momentum after the inelastic collision? 0. As you observe before and after, what happened to their total momentum? It is still the same. So it means the momentum is conserved or not conserved? Okay, the momentum is conserved. Okay, right now, okay, are you with me, class?
Yes.
Okay, right now, we have the formula that we're going to use for computing elastic and inelastic collision. So, elastic collision, M1VI1 plus M2VI2 is equals to M1VF1 plus M2VF2. While in inelastic collision, M1VI1 plus M2VI2 is equals to, open and close parentheses, M1 plus M2, then V. Okay, and these are the keywords. Okay, so our activity right now is what we call brain workout. So what we are going to do, practice how to analyze and solve the following problems. So we have the same rubrics for scoring. If you got 20 points, you are outstanding. 16 to 18, proficient. 10 to 14, apprentice. And 0 to 8 is novice. Okay, so I'm here. Okay. Okay, now I'll give you at least 6 minutes. Okay? So, 6 minutes, start now. Yes, you can use that to write down your answers. Okay? 6 minutes for computing your sample 2 problems. Okay? Then is similar to equation. Okay? Okay, so 6 minutes.
You can use your calculators or cell phone for calculation purposes.